let's go ahead and start writing this stuff down. So we have significant figures. Now, while you're sitting here and you're writing down these notes that we're talking about, let's think a little bit about what the word significant means, because it's kind of important in chemistry. When we talk about significant, we're really talking about like important. So really what we mean is important numbers when we talk about significant figures. In reality, what we talk about when we speak about significant figures, it's really about how precise we can be in our calculations and our measurements and everything that we need to do. So for example, if you remember from one of our very first lessons when we talked about how we read a graduated cylinder or a thermometer, one of the things that we talked about was this idea of level of uncertainty, right? So as we discussed, if we have a thermometer and it's measuring like at a graduated cylinder is measured at 45 milliliters, right? And then it goes by one, so 44, 43, get the idea. So 44, 43, 44, 44, 43, 42, 41, and then 40 down here, right? And let's say we read the watermark right at the meniscus and we see it right here. Okay, so we would take our reading and we say, okay, so that means that our volume here is roughly about 42 point, right? So we would say like 42 basically, okay, before we do that. But as we talked about, we also take this one level of uncertainty and we say to ourselves, we can add one extra digit, which we count as kind of like a guess. So if I look at that, I see it and I'm like, okay, well actually it's 42, but not 42 exactly. I would say it's 42.1. Understanding that this last number is our one level of uncertainty that we have. Now, what this allows us to do is actually add, which we'll talk about today, one extra significant figure. Now, you may not know what this means just yet, but we are going to talk about this. So instead of having a value that's worth only 2 sig figs or significant figures, now we actually have a third one. And what this allows us to do is to be a little bit more precise in our calculations and other measures that we take later on, saying that I can pretty much guarantee you that not only is this number right here accurate, or this number right here accurate, but the number in the 10th place is also a level of precision that I can guarantee you, right? What I can't do is I can't say, okay, well, you know what? I can also guarantee this 0 and this 0 because I simply can't. I can't guarantee that much precision all the way out to what I suppose would be the 10,000 or the thousandth place. But I can say that I would guarantee the amount of precision when you get all the way to the 10th place. So these can't guarantee. Like I wouldn't be able to say it's 42.100 milliliters. I can't say that. But what I can say is that it's 42.1 milliliters worth of fluid. All right. So that's why we use significant figures, because it allows us to give us a little bit more of a precise measurement or precise calculation when we do those kinds of things in experiments or any kind of work that we do in chemistry. Now, what becomes kind of important then is you have to be able to read exactly what are significant figures. So there's some rules that we're going to talk about when we talk about the rules for significant figures. And that's kind of what we're going to talk about today. The identification, and then what do you do when you do any calculations to ensure a level of precision when you're doing those things. Okay? So let's talk about the very first thing. So the very first rule that we're going to talk about, we're going to call it rule number 1 for sig figs. And it's probably the easiest rule out of all of them. Rule number 1 basically states that all non-zero integers, as long as I spell that right, all non-zero integers are significant. And what I'm saying is that all non-zero numbers are important. And some of you guys are probably saying to yourself, okay, well, Mr. Mings, that's great, but what is a non-zero integer? Well, just like the name kind of implies, it is any number that is not a 0. So let's say, for example, that I measure something, let's say on a thermometer or on a graduated cylinder, and I measure it to be, let's say, as an example, we would say that it was 12.4 milliliters, right? Since we're measuring volume, we would measure volume in milliliters if it was a liquid, Okay. Don't ever forget your units, by the way. We'll talk about that later. But yeah, when you write down any kind of measurement, always, always, always make sure that you have your units written down. So then I would ask you is like, okay, well, how many significant figures does this number have? Okay, so since so far we only know one rule, we're only going to apply that one rule. And that first rule states that all non-zero integers are significant. So what I always tell students is like, all right, we'll take a look at the numbers that we have. We have a 1, we have a 2, and then we have a 4, right? And we say to ourselves, okay, well, if we're listening to the rules that Mr. Dominguez just told us, we would say that the number 1 is significant because it's a non-zero integer. The number 2 is significant because it is also a non-zero integer. And the number 4 is also significant because it is also a non-zero integer. See? Pretty easy. So we would say here that this number here has 3 sig figs. Sig figs is just an easy way to say significant figures. And it's kind of cool to say too. Sig figs. Got to make sure it's plural. All right? So sometimes you'll hear me say 3 sig fig newtons because I love fig newtons. They're delicious. All right. So that's a pretty easy one, right? Not too bad. It's always the first rule that we apply when counting how many sig figs you have. Always find the non-zero integers because those are the easiest to find. All right. Now we get to the next 3 rules. Now the next 3 rules are all kind of the same in that we are specifically talking about everything that is a 0. So we talk about these as the 0 rules. Some teachers like to write them as like rule A, B, and C, whereas I just simply like to say, okay, we're going to split the different rules, 2, 3, and 4. So rule number 2 is probably the easiest of all the 0 rules, and that is, because it's an absolute rule, and I'll show you what I mean in a bit. Rule number 2 states that all leading zeros this is important, are not, I'm going to underline the not part here, so I'll make it all capital, let you know how serious it is, are not significant. Now, I know some of my higher achieving students right now are like, well, Mr. Dominguez, I know exactly what you're talking about. You said the word leading, right? Leading simply means zeros that are in front of non-zero numbers. So, for example, let's say we have a number that looks like this, right? And we say that it is 0.0001, right? And if I were to ask you, okay, well, how many significant figures are in that number? Well, much like we talked about, the very first number that we identify is the easy ones. And as we talked about before, the easiest numbers to identify are going to be the non-zero integers. Well, you're like, well, Mr. Dominguez, there's one right there. So we have one non-zero integer. Okay, but what about the rest of the numbers? What about these numbers right here, right? What about the 0, the 0, the 0, and the 0, right? What do we do about those numbers right now? Well, just like we discussed before, we would say to ourselves, okay, these, we first have to identify what kind of zeros they are. Well, since they're in front of a non-zero integer, we would say that this number, this number, this number, and this number right here are all leading zeros. And therefore, based on rule number 2, are not considered to be significant. So we're going to cross those bad boys out. So what this basically means is that I can only guarantee the level of precision up to one significant figure. So the answer to this would be 1 sig fig, right? And the reason why is because there's only one non-zero integer with the rest of the numbers all being leading zeros. So we would say that it's not significant. And that can be sometimes confusing for some kids, so I'm going to give you another example here. So example number 2, let's put E sub 2, right? And we'll say that we have this number here. So let's say we have, this is kind of like a silly example, but we'll just say 0.000000015. Okay, so right now in your head, when you're listening to me talk real fast, identify how many sig figs there are before me saying anything. I'll give you guys like 5 seconds. Now, if you said 2, you were 100% correct. Now, let's kind of figure out why 2 is the case. So let's do like I said before. Let's identify all the digits first. And we'll start off with the easiest one, which is identifying all the non-zero integers. So there's one right here, the number 1. The number 5 is a non-zero integer. So far we got 2, okay? And then all these other zeros right here, well, just like we said before, these are all non-zero. These are all leading zeros. So these are not significant. So that one's gone, that one's gone, that one's gone, that one's gone. You get the idea. So therefore, this number only contains 2 significant figures. All right, so we would say this number only has 2 sig figs. Okay, rule number 2 in the books. Good to go. All right, well, now we get to still an easy rule. Maybe not as easy as the first one or the second one, but still pretty easy. And it's another 0 rule. So rule number 3 states the following. All captured zeros, I'm going to are significant. I caught myself. Significant. Okay. What I'm saying here is that, just like the word implies, this is one of those absolute rules where I'm saying all of them, and I'm saying all of them are significant. Okay. Now, what's new about this is you maybe not know what this is right here. What is a captured zero? Well, let's first stop and think about the word captured. Like, what does that mean? What does captured mean? Well, captured means it's basically anything that's stuck, right? You're being held, right? So when we say captured zero, it's basically any zero that's in between 2 other significant numbers, right? So as an example, I would give you something like this. Example. And I would say, look at this number right here. So we have 1,001. And we're going to approach this the same way that we approached all of our other rules, by simply identifying what all of the numbers are there. So we always start with the easiest one, right? That's the non-zero rule. So there's 2 significant figures because these are non-zero integers. I'm going to write that down, non-zero integers. But then we take a look at the rest of the numbers. All right, we take a look specifically at these zeros right here. This one right here, and this one right here. And we say to ourselves, okay, well, what kind of zeros are those? Well, just like the name implies, those are zeros that are caught in between 2 significant numbers. These 2 significant numbers. Specifically, the one right here and the one right here. So we would say that in this example, we have 2 captured zeros which are considered to be significant. Let's put captured right here so you know what kind they are. Captured. They're caught in between. So the answer to this, when I ask you how many significant figures does 1,001 have, 1,001 contains altogether 4 sig figs. All right. Now to kind of put it all together, we're going to give you another example. And this example is going to be incorporating all of the rules we've talked about so far, which is sometimes going to be the case. A lot of times it's going to be the case. Once you guys get better at this, you'll be using all the rules all at the same time. So here's that example that I was giving you guys. So let's say we have this number right here. We have 0, I got a spider on me, 0.00010003. And I'm going to ask you guys, okay, let's identify how many significant figures there are in this number. Like most of us, we would do exactly what it is that we were talking about, and we start incorporating all the rules that we had originally, which is to say, okay, let's look at the non-zero integers, and let's look at all of our zeros. So that's what we're going to do again. So the first thing we're going to do, we're going to identify our non-zero integers. Here's one. Here's another one. All right, these are non-zeros. And then, so we'll say, I'll put a little line right here so you know I mean non-zeros. Non-zeros, so you know what each line represents. Let's spell that right. There we go. And then we're going to look at the other zeros. So I'm going to look at, in this case, these zeros. That one right there, that one right there, that one right there, and that one right there. And then we have to be able to identify what kind of zero those are. Well, that's rule 2 because these are all leading zeros. And as we talked about before, leading zeros are not significant. So we don't count those. So I'm going to put leading zeros so that we know what the red means. Leading zeros. And then we have another set of zeros over here, another classification, and that's these guys right here. That one, and that one. Well, these are all captured zeros. And we know those to be captured. We know those are significant. So altogether in this number, we have, we go to answer the question, 1, 2, 3, 4, and 5. 5 sig figs. So that would be the answer to that one. See, pretty easy. So far we have 3 rules altogether with only really 2 more to go. Pretty simple. So rule number 4 is probably the most challenging of all the zero rules. And that's only because there's a couple things you have to consider. So we'll talk about that. So rule number 4 states as follows. Trailing zeros are only, so this is the first time we don't use the word all, are only, oh, I put only? There we go. Only, I'm going to underline this because it's important, only significant under one condition. Let's talk about what that condition is right now. Are only significant when they come after the decimal. AFTER, after the decimal. So you can see that this is going to be the first time in which you have to consider a separate set of rules, right? So if we have trailing zeros, just like the name implies, the word trailing simply means that they come after the numbers, after significant numbers, right? Specifically non-zero numbers. So if they come after it, the only time they're ever important is when they come after the decimal. So I'll show you an example. So let's say that we have a number that looks like this. Boop. And let's say the number is 1,000. 1000. Okay. Now we do the same thing that we've done before. We identify first and foremost all the significant numbers by identifying each of the rules. Start with the easy ones. We have the non-zero right there. Okay. And then we take a look at these zeros right here. We have 1, 2, and 3. Now some of you guys might say to yourself, well, Mr. Dominguez, there's 4 sig figs because we have 4 significant numbers, 1 non-zero integer and 3 trailing zeros. And I would say, okay, you're correct. They are trailing zeros. However, these are not significant because as the rule states, they have to come after the decimal. That's the only time trailing zeros are significant. So to show you a better example of this, I'm going to write not the same number, obviously, but a number that looks kind of like that. Instead, though, I'm going to put, instead of it being 1,000, I'm going to put 1.01. In other words, just the number 1, right? And let's take a look at this. So just like before, right, this one only has 1 sig fig, but this number is a little bit different because, just like we said before, there's 1 non-zero integer, but we have these 3 zeros here, 1, 2, 3. And you've identified them as trailing zeros. You'd be correct. However, we see a decimal right there. Oh, there's my decimal. So since all these trailing zeros come after the decimal, then we say that now this number has 4 sig figs because each one of those zeros is important, once again, because it comes after the decimal. So we call it as such. So we have 4 sig figs. Pretty neat. All right, let's do another example. Just kind of bring this home. So this is example 2. And this was going to incorporate pretty much all the rules we have learned so far into one nice number, because that's going to happen from time to time. So let's say that I have a number that looks like this. Let's say we start off with 0.001,050, right? So when we take a look at this number, just like we did before, we're going to identify all of our significant figures starting with non-zero integers. We have 1 right there, 1 right there, Then we're going to go to our zeros and we're going to identify them. So these right here are leading zeros, which are never significant. So we know that, so I'm going to cross them off right off the bat. Then we go to this zero right here, right in the middle. And we know that's a captured zero, so that counts as a zero. So far we got 3. The last number that we got, or the last significant number that we got, is this guy right here. All right, now we have to identify what kind of zero that is. Now this zero is a trailing zero because it comes after significant numbers. But since it comes after the decimal, which is all the way over here, it is considered to be significant. So therefore, this number has 1 significant figure, 2 significant figures, 3, and then 4. So we say this number has 4 sig figs. And that's using all of the rules that we've talked about so far. All 4 of them. So if we were just talking about like identifying sig figs, that would pretty much be it. That's the way you identify significant figures. But sometimes there's other cases in which it's good to just kind of figure out. So this is going to be like an extra to rule number 4. Not really rule number 4, but just an extra part of rule number 4. So one of the things that often confuses people, as another example, is if I have a number that looks like this. Let's say that we have like 1,000, or let's say 10.0. And you would say, Mr. Dominguez, that number only has 2 sig figs because you have a non-zero integer and you have 2 trailing zeros, but only one of them is behind the decimal, and that's that one, right? And you would say to yourself, okay, well, that one doesn't count because it's a trailing zero, but it comes before this one doesn't count because it's a trailing zero, but it comes after or before the decimal, so it doesn't count. Well, in reality, this number right here is significant. This number here is significant. So technically, this number right here is a captured zero. So therefore, that's a significant number. So we would say that in this case, there are 3 sig figs. Okay, cool, right? Nice and easy. One more like extra example before we move on to the last rule. And that's sometimes you'll see numbers like this, 100. And you'll say to yourself, okay, Mr. Dominguez, there's only 1 significant figure, once again, because it's a non-zero integer, and there's trailing zeros, and they come before the decimal, so therefore there's only 1. Sometimes what you'll see people do, and this is kind of a weird way, I don't like it, but people do this, they'll put a decimal place, let's say like right here, just like that, saying that it's 100, all right? Technically, this number now, instead of only having 1 sig fig, actually has 3. It still follows all the rules that we've been teaching you guys. But what this is basically telling you is that this decimal tells me that this number has exactly 100 of whatever it is that you're measuring. It's not like 100, like maybe it's 100, maybe it's 101. No, it's telling you that you have exactly 100. So because of that, each one of these numbers is important. The 1, the 0, and the 0. So you don't want to treat these as captured zeros. And the decimal is acting as a captured or a wall to say that these zeros are also captured. Now, I try not to write numbers like that because I think it's kind of dumb. But you do see numbers like that. Just so if you ever see them, just know that's what it means. Okay? All right, last rule. Rule number 5. Finally to it. Rule number 5 has to do with scientific notation. Now, if you remember algebra, you guys, I misspelled that. Scientific, there it is. Notation. All right, so scientific notation, which if you remember a little bit of algebra, you guys probably dealt with them. The rule for scientific notation is all numbers are significant. Oh, misspelled that. How did I misspell that? Whatever. Are significant. So, for example, remember that the reason we use scientific notation, well, I'm going to give you guys a lesson later, but the reason we use scientific notation is to show really, really big numbers or really, really small numbers in a way that's much easier to write out. So let's say we have a number like this. Let's say we have 6.25 times 10 to the second. And let's measure it, so we'll put it in, let's say, meters or whatever. So basically, if I wrote this number out again, it'd be 625. Now, because we're reading scientific notation, what I'm basically telling the reader is that when I calculated this, that all of these numbers are important. If not, I wouldn't have written them down. So technically, they're all significant. So this has 3 sig figs. But if you really pay attention, I mean, it still follows the rules. You'll still see capture zeros and leading zeros and all that stuff. But we typically don't write scientific notation with leading zeros at all. We kind of leave them out, and we only incorporate captured, trailing, or non-zero integers. So that's probably the second easiest rule to follow, is that when you write in scientific notation, all of your numbers are considered to be significant. And no, turkeys, before you guys ask the question, these numbers right here are not part of the number. They're just telling you exactly how many places they are or decimal places they're going to have or whatnot. Okay, that's all there is to significant figures. There's a worksheet that goes with this that I want you guys to take care of. If you have any questions, please let me know. Send me a message on Teams, and I will see you guys tomorrow. Take care, guys.